Hey, this is MIT Integration Bee 2017, problem number 7. We've got the integral of hyperbolic cosine inverse of x dx. Now, because we're trying to integrate an inverse function, that can be a little tricky. So typically what we want to do here is use integration by parts. So let's set that up and let's quickly review integration by parts. Okay, so we have here our integration by parts formula. And the thing to notice is we're just breaking our integral into two pieces, two functions. And when we have that, we have a way to break this up into something that we can handle. What it really allows us to do is if we have a part of the integral that we don't know how to integrate, we can actually differentiate it and we can kind of avoid the integration or get it in a way we can handle. Now, looking at our integral, we don't have two parts, we just have one. We just have this hyperbolic cosine, but we can always create another function. We just do that by creating a 1. You'll notice most of the time when I do integration by parts in these videos, I'm doing the DI method or tabular integration, and that's where we create two columns, D and I. In this video, I'm just going to do the extra steps, but it's still going to mirror the DI situation. I'll kind of label it this way so we can see what's happening. So the thing we want to differentiate, we're going to call our U, this piece. And then the thing we want to integrate, we'll call dV. And we definitely want to differentiate hyperbolic cosine inverse because we don't know how to integrate that. So that's kind of what we're kind of do it how it's convenient for ourselves. So we'll assign U. So we're going to assign our U to this inverse hyperbolic cosine of x so that we can differentiate it. And then we'll take that 1 and just make it our dV. Now when we differentiate this, we're going to end up with 1 over the square root of x squared minus 1. We can put a dx there if we like. Then integrating 1, we're just going to have x. So now that we have all the values in our table, we can go back to this formula and we can integrate this. So starting, we have our uv, and again, this is like in the DI method, when we do the parallel, we take that as our part of our answer. So this uv value is going to be x cosh inverse x minus this integral, v is x, and then our du is going to be dx all over square root of x squared minus 1. So we have part of our answer, we just need to integrate this. This second piece here we can do with the u substitution. Let's just, although we use different variables, we don't want to confuse with the u we have up here, so let's do a t substitution. So we'll call t equal to x squared minus 1, and then our dt is going to be 2x. We have an x up here, let's just create a 2x, and we'll put a half here, so we're not changing the integral. So then, let's see, let's rewrite this and make our substitution. So we have x inverse cosh minus a half. Then we have here our dt in the numerator and the square root of t here. But now with the square root of t in the denominator, I'm just going to rewrite this just so we can use the power rule clearly. So I'll write this as 2 to the minus 1/2 dt. And then I think we can finish this off, or at least do our integral. So we're going to have x cosh inverse x minus half. This is going to be the integral of t to the minus 1/2 is going to be t to the 1/2 times 2. This is going to cancel here. And then so for our final answer, we have x cosh inverse x minus the square root, and we'll just plug in our t right away. And that's going to be x squared minus 1 plus c. And so a couple things I just want to notice in relation to the DI method, just reiterating again, the UV part is this diagonal, so we just pulled the solution from this diagonal, but then this row, the last row, is going to be the integral as we ended up taking v du, and that's this piece right here. So the DI method, we're actually just kind of doing some shorthand, but we're also allowing to go beyond 2 rows because we can do this repeatedly. So that's it, MIT 2017, number 7. Thank you for watching. Please like and subscribe. Have a good day.